And I'm live. Hello, and today is 29th of July 2025, Tuesday. And from now on, since I need to get to a rating of 2000 by the end of this year, which is 5 months, I need to change things up. I have to do targeted practices instead of blindly, mindlessly solving questions. So from now on, I will be doing practice on specific topics, and in today's stream I will be solving binary search problems. And even though it is a basic topic, still I am not, my ability in solving binary search problems is not very intuitive. It is not at the subconscious level, and I do have to think about it when I'm applying it. So let's make it subconscious. And that is bad. Shit. My face is very small right there. Let me fix that. This I should have tested this before the stream. I guess now it is fine. Is it? Let me shit. Uh yeah, let me see. Nope, it is not. It is not fine. And how am I supposed to see the inner thing? Yep. Then I would have to like unhide OBS. Right. Let me do that. Yep. Now let me just fix this and we will begin the stream. Okay, put that behind myself, and now I can hide OBS again. Yep. And I am in the middle of the screen. And why is my photo here? Yep, 2 viewers already. And now, yep, binary search questions. I was reading this competitive programmer's handbook, and it was, yep, here, binary search. And in binary search, the data that we are working with has to be sorted in either ascending or descending order. And you take advantage of the fact that the data is sorted in one way or another. That is one thing that you can apply binary search at. And there's also another thing where you can apply it. But the essential thing is that every time the step that you are taking forward or backward, it is getting half, and the data that you are searching in also gets half. That is why binary is like 2, so it gets half. And here the author described two methods of going through stuff, and one is when you take a lower bound and an upper bound and always find the middle value in the lower bound and the upper bound between L and R. And then there was another method in which you decrease the step with which you are moving forward and backward. And I wouldn't say well versed with the left and right method, but I will, like, I guess after writing it few times, it would get better. But this method, I have read about this here for the first time, and thus I would have to work with this. Here you start with a step. Your step is B. Step size is n by 2, and every time you are dividing that step into half, and you are doing this till your step is 1, and when your step becomes equal to 0, you go out of the loop. And yeah, this is what you do. You change the direction of the step, and either you add it, or you only add the step when, yeah, your starting index is k, and you only add the step when you know that you can go step amounts of time to the right without skipping your target. And let's try to implement it in a few questions in lead code, let's say. Binary search. I will start with easy questions, and then I will move on to hard questions. Therefore, I can sort this. And like even yesterday, I was feeling embarrassed when I started with easy questions. But the thing is that I do not want to get discouraged very early on. So I will do a few, 2 or 3 easy questions, and then I will move on to medium questions, and then I will see, maybe I might be able to solve a hard question also. Let's see, binary search. But the main objective of this is to get used to binary search, to get comfortable with binary search, so that I do not have to give conscious effort when I'm implementing binary search. Lead code 268. Let's do this. Given an array nums containing n distinct numbers in the range 0 to n. Okay, this is the range. This is just a permutation, and containing n distinct numbers. So one number is not there because we are starting with 0. Return the only number in the range that is missing from the array, and their order is whatever it is. Here the missing number is 2, and this is supposed to be a binary search question, but how would you can sort this and then find the element. Yeah, instead of but instead of sorting this, sorting would take n log n time. Instead of that, I can just linearly search it, and I think that would be the best method. Linear search. And for that, I can create a Boolean array of the same size, and bool p present of uh, vector bool p size n, or more like nums dot size. And yes, I am coding in here, but yeah, that is bad. I do not want to code in lead code. So hey, teamwork is not set. Teamwork attach lead code, and where am I? The question number is 268, 268.cpp, and this returns an integer and find and takes in, what does it take in? A vector of nums. Oh wait, I wrote a key map for this thing. Space print lc. Yep, there we go. Return an integer, find, and this takes in vector of integer reference. Okay, does not matter, reference or not. And then create std, or without std, vector of boolean p size a dot size, and initially everything is false, and Can I do find in this? No. There should be a better way than this. I can maybe create a bit set, take and with some number, and the number that I get would tell me what the missing number is. Now, there is a missing number. Okay, let me first write a normal implementation and then I will write a better implementation. Okay, so in this I would just linearly search, and whenever I see a number, I will add it. So the size has to be +1. And will I have to do a linear search twice? That is 2n, because I would look for false in my Boolean array. Shit, that is bad. But let's see auto x a and p bracket x equals. This is so bad. This is bad. And how can I even apply binary search in this? And then int answer equals 0, or like nothing, and return answer at the end, and here for int I equals 0, I less than a dot size plus 1 I plus plus, and then if not p I, then answer equals I, and also break. So this should work. Let's see. Or this might not work. Vector bool, what is the problem? Because I am okay, nums. It is taking in nums, not a. Okay, my bad. And I have a better thing. Yo. Okay, go up to A and S. Go. Is there a no more? Shit, there is no more A. 268.cpp. Copy and paste this thing here. Let's see, and it does work. Of course, it works, but shit, it is also optimized. How is it optimized? It it is a very bad implementation. And missing. Okay, n is the size, total sum. Okay, shit, yes. Find the total sum, and whatever is the difference, that is the answer. Shit, that is cool. That is cool. That also takes n time complexity. We go of n, and but this is smarter. This is smarter than what I'm doing here. The time complexity is 2n. This is smarter. That is actually cool. Yeah, that is cool, and that is what I'm going to implement. That also takes less space and stuff. Long, and also int. Uh, okay, shit. Int z size is nums dot size, and then long, TS total sum equals n into n plus 1 divided by 2 or sz, and here sz, and long, and then they used a function called accumulate. What does that do? That function takes in a first iterator and the last iterator, and okay, there is no detail about. Can I go to definition? Okay, I am trying to go to definition. GD, uh, GD, go to definition. Okay, definition search, Vim definition. I remember writing a key map for this thing, for going to definition. Yeah, right there. Control closing bracket. Okay, go back and control closing bracket. That is the definition, which is right there. That is cool. That is actually cool. And below, I can remove that. Accumulate, take nums dot begin and nums dot end, and a long sm equals this thing. No matching calls. What does it want? What is the syntax of this thing? Zero. That is init, initial value. Okay. Start with this and return sum minus total sum, or the opposite of that, right? Total sum minus sum. Just 4 lines of code which I have copied off of the internet. And this should work. And it does. So done with missing number thing. Count complete tree nodes. Yesterday I was trying to do this question and I read the editorial for this one and it didn't make a lot of sense. I don't know how to do this one, but let's go with this. First bad version. Let's see that. You are a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails the quality check. Okay, since each version is developed based on a previous version, all the versions after a bad version are also bad. Suppose you have n versions and you want to find out the first bad one, which causes all the following ones to be bad. You are given an API bool bad version which returns okay, then I have to find the first bad version. Okay, that is int is bad version. That is just what I have to call. Can I just call that? Okay, return is bad version 1 if bad. If one is bad then 1, else 2. And this is simply like trying to see if the API works. And of course it would work, but I want to see it. Okay, it seems to be working. It seems to be working. Okay, now I need some things which do not change. Loop invariance. Yep, loop invariance. That is the properties which do not change after every iteration of a loop. And I start with those properties, and since I know that they are true at the beginning of a loop and after every iteration they do not change, I can suppose that when the loop exits, they have still not changed. And that is with which I am going to start with. So int L and R. L is going to be -1 and R is going to be N. And is N inclusive? It is N is inclusive. So here the thing is that L always points to an element that is true and R always points to an element that is false. So when I exit, L should be pointing to an element that is true and R should be at false. So whatever is in the middle, that should be the case. That should be right. While R minus L greater than 1. And I saw this yesterday while I was reading something, and I should go from here. 278, not CB. Delete this boilerplate and end find and does not matter. Okay, while this okay, and this okay, return answer, which is answer equals 0, and okay, I can make I equal to 0, L equal to 0 actually, because 1 is 0 is not included in the versions with this, and then in mid equals L plus R divided by 2, or maybe a better version would be L plus R minus L divided by 2, because if L and R are very big numbers, then it would cause integer overflow. So that would be bad, and this is better. Mid, finding their mid, and if mid, if what is bad version, right, is bad version. Let me define it here. Bool is bad version takes in an integer, and here is bad version takes in mid. If it is good, then L equals mid. Else, if it is false, then R equals mid. And okay, R and L are always decreasing, so that is cool. And there is always one bad version, and I guess R is the answer at the end. I can simply return R. Yep. Yo. Mm, okay, my bad. My output is 1 here, and here it is 2. Why is my output 1 here? Bad was 4, Why did I output 1? So I started with L equals 0 and R equals N plus 1. Shit. L is always good and R is always bad. And if mid is bad, then that becomes R, else it becomes L. Okay, okay, that was a mistake. Now it is better. And loop invariance holds, or it might not hold. Why, what is the problem? Use test case. And is this bad is the last one? And okay, in case that bad is the last one, then I return. Okay, then I return R minus 1. Okay, if L equals N minus 1, then return R minus 1. Yep, else return R. Right. Yep. Okay, that is too big. Okay, and I can say that R is always, the last one is always bad.